Okay. Hello everyone and welcome to the DCC NIT-A YouTube channel. Today we are going to discuss problem C of educational round 143. Let's see the question first. A tea manufacturer decided to conduct a massive tea tasting. There are n sorts of tea that will be tasted by n tasters. Yeah, so for every tea there is a milliliter of quantity for that tea, and the jth taster can drink P of j milliliters of tea. Basically, array B gives you the quantity of how much tea can be tasted by one taster at a time, and array A will give the quantity of the ith tea. Now let's see the operations. During the first step, the ith taster will taste the ith sort of tea, and the ith taster drinks minimum of AIBI, and AI gets decreases after whatever amount he drank. In the next step, the ith taster will drink I minus one sort of tea. And the third step, he will drink I minus second. In the end, we need to find out for each taster how many milliliters of tea he or she will drink in total. To understand this question, let's first see an example and see how it's working. So here's the example. Here's example one. Let's zoom in a bit. So this is your this is your array A, and this is your array B. Array A shows what's the quantity of tea, like T1, T2, T1, T2, T3, and array B shows that how much quantity of drink of tea that this taster can drink at a time. So let's denote T by small t, and let's denote taster by capital T. Okay. Now in step one, in step one, the ith taster will drink ith tea. So this will become 9, 10 minus 9, 1. This will become 20 minus 8, that would be 12, and this will become 50 minus 6, 9. So this is the T, this is the A remaining after step 1, right? And for the tasters, T1, T2, T3, T1 drank 9 ml, T2 drank 8 ml, T3 drank 6 ml. Now, in step 2, 9, for 9, the I minus 1 is not there. So now T1 will just stop drinking. For T2, I minus 1 is T1, right? For taster 2, the I minus 1 is T1. So he will drink from T1, with the remaining T1 is 1. So he can only drink 1 milliliter of tea. So this will change to 0, and we'll add 1 in T2, taster 2. The taster 3 will drink from T2, which is remaining is 12. He or she can drink 6 milliliter of tea. So this will remain 6, and we'll add 6 ml to taster 3. T3 won't change, so we'll just say. So this is A after step 2. Now step 3, taster 1 cannot drink anything. Taster 2, for I minus 2, there is nothing. So taster 2 cannot drink anything. Taster 3 will drink T1. And the remaining T1 is 0, so it won't change. So everything would be the same, A. And the final, we have finished all the steps. There are only 3 steps, because in the fourth step, T3 also won't be able to drink anything. So number of steps are finished. Now our final answer is T1 is for T1 it's 9, for T2 it's 9, for T3 it's 12. So this is the operation which is happening in this question. And so 9 and 12 is the solution. We just need to print out what is the milliliter of tea that every taster will drink. Now let's see how to solve this question. Let's first of all see an operation. What we see in that is T1 can only drink T1 tea. Taster 1 can only drink T1. Taster 2 can drink T1 or T2, provided T2 is remaining. T3, taster 3 can drink from all the above, T1, T2 and T3. It will first drink from T3, then T2, then T1. So basically, for any nth taster, he or she can drink from T1 up till Tn. Of course, if T1 is remaining, but of course she can try, right? So there would be n steps for every size n array, and this is an observation. Let's take this example once more. Just a second. Let's take this example here, and let's try to find out some observations in this question. Now, this is A, this is B. Now, as I told you that T1 T1 can be drunk by all of the tasters. T1 is also here, T1 is also here. So what we need to see in this question is that uh, till which taster does this tea remains, right? Starting from ith taster. And how can you do that? Via prefix sum. If we take the prefix sum of this array, prefix of b, this will become 9, this will become 17, and this will become 23. So what we can see is that till which index thus this 10 remains, it will become 1 in this and it will become negative in this. So basically till index 1 only it remains, right? So the index 0 can take all of the SIP, like the whole SIP, he can take 9, 1 will remain, 1 will pass on to index 1, and index 1 can take only 1 ml of T1, right? If we take if we take T2, T2 can only be drank by T2 and T3. So we'll apply, if we see from here, 8 and 14, our T remaining is 20. How much till so if we see, our T remains till the last index. So both of them will get the appropriate amount of T, which is 8 and 6, right? And for 15, the prefix sum would be 6 only. If we start the prefix sum from here, and all the T is remaining after this, so 6 will be added to its answer. So basically for index 1, 9 is the answer. For index 2, 1 plus 8 is the answer. For index 3, 6 plus 6 is the answer. So this is how we construct our solution. We just see that how far can T1 go and add accordingly, how far can T2 go, how far can T3 go. And this is the basic solution of this question. Now to implement this, it's a hard part because we have to use like 2 3 techniques in this question. So I'll tell you how to implement this. Let's move on to our code first, and let me show you how I have implemented this. Just a second. Yeah. So initially I have taken an input. I've taken A input, B input. Let's forget this for a moment. I have made a prefix sum for this B array in pre. Now, what I have done in this question, let's see. How have I implemented this? Cool. For 10, I need to see till which index does it goes. What's the best tool to find this? Upper bound. Now, for those of you who don't know what upper bound is, I think you should go and check out GFG for that. But I'll tell you in brief. If I okay, just a second. If I have an array like 1, 2, 5, 8, 19, 7, 20, if I have a sorted array and I have a key of 5, the upper bound for this would be this index. Why? Because it tells you the index at which the number is greater than 5. If I take the key of 6, then also this index will point. It will point to this index. If I take 9, then this index it will point to 14. If I take 24, then it will point to dot end. That means after this, it will point at this index, which is nothing. We need to backtrack. But yeah, so this is what upper bound is. It tells you the index at which the number is greater than key. Strictly greater. If I choose 5, then also I'll get this index only. I won't get 5. So this is what upper bound is. Let's see for this example. Uh, I need to start my, I took a iterator Initially my iterator is here, pre dot begin is pointing here, plus I is 0, so it will be pointing here, the iterator is pointing here, and I do a upper bound from this till the end of the array, of the prefix array, and my key is a of I plus sum. What is sum? I'll tell you later. Initially the sum is 0, so 10 is the key. So in this I'll get this index, so this index will come out to be 1 and its value is 17. Let's forget this for a moment also. Now let's see how I implemented this. I'll decrease my index, I'll move on to 9. Now I am at 9, right? I am at 9. So let's make this array here, 9, 17, 23. I am at 9. Why I have decreased it, I'll tell you again, just a second. Now I'll use the concept of partial sum. So basically in the end, the answer we need to give is for every index. So to do that optimally, we'll make a result array, result vector of size n plus 1. So 1, 2, 3, 4. Initially everything is 0 in here, right? Okay, just a second. 0, 0, 0, and 0, right? Now what we'll do is that we saw that till index 0 we can provide t to everyone. So what we'll do, we'll increase index 0 by 1 and decrease index 1 by 1. What will happen is in the end, if we take the prefix sum of this, we'll get 1, 0, 0, 0. If we take the prefix sum of this array, 1 minus 1, 0, 0. What this will do is that we can find out that, okay, this person was able to gulp t this number of times. So we'll just multiply it by 9 to get our answer in the end. So that's the logic which I've used. Initially partial sum, then prefix sum. I'll tell you the implementation of this example. Yeah, for the example, this will become 1 minus 1, right? Plus 1 minus 1. And one more thing I have done. If pre of index, that means 9. If 9 is less than 9 minus sum is initially 0. If 9 minus 0 is less than equal to 10, which is true, that means there is 1 milliliter of t which is left. So that would be taken by the next index. So taster 2, m of index plus 1, index plus 1 is taster 2, right? Because index is taster 1. Map is nothing but it stores the extra t which any taster drinks. So I just increase it by a of I minus pre of index plus sum, basically the remaining t. Sum is initially 0. Now I'll tell you what sum is. So basically what I did is that I had a map. In that map, in that map, I'll increase the value of 1 to 1. That means my index 1 will have 1 milliliter of t. And this is different. This resultant that is different. It shows that what amount of gulps it has taken. Basically, I'll tell you in the end. Now, I've increased my sum. What is sum? Remember I told you that if I have to take for this index, I need to start my prefix array from this. Now to solve this problem, how will I change my prefix array? What I did was, in the key only, I added the previous sum. Like if when I start my upper bound from this index, what I'll do is that if my key was 20, right, I'll make it 29. Why will I do that? So that the prefix sum will come out to be, so that upper bound will come out to be correct. Because the prefix sum is 9, 17, 23, right? If I want to change it to 8 and 14, it would give an TLE, because if I change the prefix array every time, that would be n square complexity, because n times I change the prefix array and n times I have to loop. So what I did, I just increased the key uh, by this sum, the sum which I had to discard. So if for this the key is 6, for this the key would be 15, and for this the key would be 14 plus 9, 23, right? So that's why I did this. And okay, so 8 plus 9 is 15. Sorry, 6 plus 9, right? 6 plus 9 is 15. And for this, okay, just a second. AI plus 7. The key is 7, right? So now in this prefix sum, I need to find 15. The index that would come for 6 was 8, and for 15 is 17. So it will give me a correct solution basically. So that's the optimization which I did. I changed my key. Same for iterator. I need to find my prefix sum, apply my upper bound from index 1. So that's why I increase it by whatever index I'm at. So that's why my iterator increased by 1 here. First step 2, it will increase by 2 basically. And why I did minus sum here is that because, just a second. Okay. Why I did minus sum here is because, like, if my key is like 6, but my prefix sum is here is 17, right? So I need to do 17 minus 9, 8. And now from this, I need to subtract to tell it, okay, 2 milliliters of tea is remaining. So that's why I did minus. And I added it into the next index if it's remaining, right? A of I minus P of index plus sum. Okay, just some minor inconvenience. So where were we? Yeah. And I added it to the next index, like whatever the leftover T is. And in the end, let's continue with this example. For 20 now, the key will change to 20 plus 9, 29. And I'll start my open from here. 29, the index will fall here. I'll do minus minus index. I'll get here. For res of I, that means index 1, I'll increase it to plus 1. And for index 2, I'll index 2 plus 1, that is 3. I'll do minus 1. And this is it for part 2. And if pre of index minus sum is less than a of I. So let's see. What is pre of index? That is 23 is less than 29. That's true. 6 will be added to what? M of index plus 1. What is index? Index here is 3, right? Okay, it won't be added here. Yeah. So index is 3, right? So M of 4 would be changed to like 6, which is useless basically. One small mistake here, I think it's index 0, 1, 2, 3. Yeah, it won't be added here. Yeah, it's fine. Okay, it's fine. Index 2, index 3. Yeah, this would be index 3 because IDX is 2 basically right now. Index 0, 1, 2, 3. So IDX initially went to 3 for upper bound. I'll minus it went to 2 and then stuff like that. So this was in the step 2. In the step 3, I will go to 15. I'll add 15 plus 17. What is 15 plus 17? That would be 32. Now my key is 32 and I have to start my upper bound from this index. The index will come out to be here. I'll subtract it. I'll go to 23. I'll increase it by plus 1. I'll increase by plus 1 and decrease by minus 1. In the end, I'll get this partial sum. And when I take the prefix sum, when I take the prefix sum of this, I'll get 1. Wait a second. I'll get 1 and 1 and that would be 2. That would be, we don't need to take care of that. So this is a resultant array after taking the partial sum of this, which will give out our answer to be for this 9, for this 8, and 6 into 2 is 12. Now where is this remaining 1? This is stored in our map. So we'll just add it. This will become 9, 9, 12, and that is our required solution. That's the basic implementation of this question. Now one thing you'll see that what I have done here. So it's basically was some test case like if it's a 10 A and B is like 17. So the upper bound that will come for this is index 0 only. So basically index would also be 0 and I would also be 0. So for that test case I just have increased my map because it will be only able to drink 10 milliliters. So I just increase in the map, I'll add the sum and continue. So that's just some random optimization. You can think of other optimizations if you want, but that's the basic solution. And so in the resultant array we store whatever the max, whatever full drinks a person can drink, and in the map we are storing what partial drinks the tea taster will drink. This is the solution, and it was a really good question in the end. So yeah, this, thank you.